Hello, it's Mr. Win, and I want to talk about slope-intercept form, how we switch from standard to slope-intercept form, how do we get equations to slope-intercept form, and how we might go about graphing it, okay? So we've already talked about slope-intercept form, and we know that it's always y equals mx plus b. The nice thing about slope-intercept form is that it's in its name. You can easily look at it and tell me where the slope is, what that slope is of that line, or you can tell me what the y-intercept is. And it's simply just going to be m as your slope, b as your y-intercept. So if it's in this form, right, you can just look at it and say whatever number has that x on it, where the m is supposed to be, that's your slope. Whatever plus b minus whatever it might be at the end that doesn't have an x is your y-intercept, all right? So how do we get equations into that form? Well, here's an example, all right? Notice that your equation should always look like this, and I'm going to write it in the corner. Y equals mx plus b. Now, this equation is close. I have a number with x. It kind of looks like mx. It kind of looks like b here, right? But the thing that's not right is this y. There's a 3 on it, okay? The y is supposed to be there, but yeah, there's a 3. You got to get rid of that 3, okay? The thing about slope-intercept form is it is always going to be y equals. No matter what, you have to always have y equals, right? It says y equals b. Your equation will always have y equals. So really, if you solve for y for any of these problems, right, get y alone, that's what I mean when I say solve for y, you will turn it into a slope-intercept form, okay? So in this case, we want to solve for y. That means we want to get the y alone. That means the only thing that's on that y is the 3. So let's cancel that. And if I cancel a 3, you're doing your inverse operations, do the opposite. You're just going to divide by 3, all right? Because it's 3 times y, the opposite is divide by 3. Because if I divide by 3, those cancel out. But I have to go over here and divide each and everything by 3. So if that cancels out, I'm going to be left with y equals 6 divided by 3 is 2. All right, 2x, and then negative 9 divided by 3 is negative 3. There's a slope-intercept form. Now I know what the slope is, right? It's 2, and I also know what the y-intercept is, negative 3. Okay, let's do another example. What if it looks like this? Right, the last one, all we had to do was divide by 3, but I got a little bit more of a mess here, right? So I've got to move the x around the negative 2, but that y has to be alone, okay? So that means you got to get rid of this 4x and this negative 2, okay? And then y will be truly alone, okay? To do that, let's cancel the 4x. It's a positive 4x, right? So let's just subtract 4x, all right? Because if I subtract 4x from 4x, it cancels out, right? It'll be gone. So that means I got to go over here and subtract 4x as well. The thing is, 3 can't be subtracted by 4x, right? They're not like terms. So I'm just going to rewrite it. So negative 2y is over here. And let's rewrite it by putting the x in front. And then it's a positive 3. All right? Because I can't subtract those, just rewrite it in one line, just to make it easier to solve. And then from there, it looks like we got to divide again, right? Because there's a number on that y. That negative 2 is being multiplied with y. So to cancel that, divide. That means I got to go to each of these and divide by negative 2. So this cancels. Now you're left with y equals negative 4 divided by negative 2, right? Negative divided by a negative gives us a positive. And 4 divided by 2 is 2. So positive 2x. And then 3 divided by negative 2, well, one of them is negative. It's going to turn into a negative. But we'll just leave it as a fraction as 3 over 2. Now, you could write it as the decimal negative 1.5 if you did the math out. But fraction is fine. It gives us an exact answer. There's our slope-intercept form. So the slope will be 2. All right, the slope. The y-intercept, negative 3/2. All right. Now, what if I give you a graph? Well, same thing. You got to solve for y, okay? So over here, I've got to cancel the 7x. So if I subtract 7x from both sides, y will truly be alone now. But you can't, right? You can't subtract those. They're different terms, so rewrite it. And there's my equation. Let's graph it though. If I give you a set of x's, that means I'm going to plug those into the x, and it'll give me my set of y's. And they're just points, and I can graph, okay? So let's plug in each of those. So for -1, I'm going to do this to the side. Y equals -7, and instead of -1, instead of x, I'll put -1 plus 3. Do the math out. -7 times -1 is a +7, plus 3 is a 10. All right, keep going. Excuse me. If I do that for -1, y equals -7, and plug in 0. Sorry, I'm doing the next one. Add 3 to that. 0 times -7 is 0. 0 plus 3, which is going to be 3. So our y value would be 3. All right, let's keep going. Y equals -7. Now instead of 0, let's plug in 1. All right, and add 3 to it. So -7 times 1 is -7. -7 plus 3, -4. And the last number, -7, and I'll be plugging in 2, and then add 3 to it. That means -7 times 2 is -14, plus 3 is 11, -11. All right, from there, just graph your points. Well, one of them is -1, 10, so let's do that. -1 is here. 10 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our point would be here. All right. Next point is 0, 3. So our next point would be at 0. Go up 3. Here's the next one. 1 would be -4. So let's go down to -4. So -1, 2, 3, 4. Our point would be here. And lastly, 2 would be -11. So if I keep counting this down, 5, 6, 7, excuse me there, -8, 9, 10, 11. There's our next point. And let's just draw our line. And we've graphed it. All right, that's it. Thank you.